Hey everyone, welcome to this video. Let's talk about the transformer decoder. So, the transformer decoder, which is on the right hand side here, is similar to a transformer encoder, but there are several differences. First difference is masked multi-head attention. Second difference is multi-head cross attention. And the third difference is linear layer plus softmax. And these three differences I've highlighted in these red ovals on the decoder side. And let's go over these three key differences. First up is masked multi-head attention. So wall of text incoming. The decoder will predict the translated words one by one using its input. However, attention would allow the decoder to see future words, as we can see these two diagrams here. Essentially, if we use attention with the decoder, it could cheat and not learn effectively. This is fine for the encoder though, the seeing the future words part. And the reason why is a human translating "my name is Kevin" from English to Spanish would not be cheating by knowing "my name is Kevin" as they are translating. However, a human translating "my name is Kevin" from English to Spanish would be cheating by knowing "mi nombre es Kevin" as they are translating. Let's use masked multi-head attention in the decoder so the decoder is unable to see future words for its translated output. So masked multi-head attention stop attention scores from being calculated on future words. I think this picture or diagram is really good at explaining things. So at start "mi nombre es Kevin," at the nombre part, no attention scores are calculated for S or Kevin, which are the future words, right? Same with me. The future words are nombre as Kevin. No attention scores are calculated. But the last part of the translation, which is just Kevin, all the attention scores are fine as they are. Next up is multi-head cross attention. In multi-head cross attention, the decoder masked multi-head attention is used as the query, as we can see in this query part right here. An encoder output is used for key and value. So context-aware word bangs become the keys and values. In case you're wondering how the encoder and the decoder are connected and work together. Or another way I like to think of this or picture this is this. We have the decoder, start "mi nombre es Kevin." With the start token, the query is, I need a pronoun. The encoder says, okay, key of pronoun, and the value is my. And maybe in the middle of the translation, the query could be, I need a verb next. And the encoder says, oh cool, my key is a verb and my value is. So hopefully this diagram makes it easier to understand what is happening in multi-head cross attention. Last up, of the three main differences between a decoder and an encoder is the linear layer and the softmax. So the decoder finally has a linear layer and a softmax for the next predicted translated word. For the linear layer, output size will be vocabulary size, e.g., output size of 5,000 for 5,000 unique words. Softmax, use softmax on the output of the linear layer. Use the highest softmax output for the next predicted translated word. In the next slide, let's zoom in on this softmax linear layer part. So we have a linear layer where the output size will be the vocabulary size. So maybe the vocabulary could be like eres, soy, es, son. And maybe the last two words are tu and yo. This goes through a softmax, which gives the highest probability to the word s. And so that's our next predicted translated word in our translation. Mi nombre es, because the highest probability right here. And the decoder will predict the translated words one by one. The decoder will predict the translated words one by one using both the entire English sense from the encoder and only the currently translated Spanish words. Right, mi nombre es Kevin, as is slowly translating. But the next slide, let's better demonstrate what's happening right here. Right, so again, the decoder will predict the translated words one by one using the entire English sentence, which is the encoder output of context-aware word embeddings of my name is Kevin, right? It's always on the left-hand side. And only the currently translated Spanish words, which in the beginning is just the start token, but then it slowly grows until at the very end we have start mi nombre es Kevin as the input to the decoder, and the decoder finally outputs like this end token. All right, so similar to the encoder, a model with many layers is needed for learning complexity. So just as in this example diagram, we had 3x or 3 encoder layers, let's also use 3 decoder layers. And a way you can think of this diagram of both the encoder plus decoder or the entire transformer as a whole is that the encoder understands the English sense for translation, which is my name is Kevin, and the decoder generates the Spanish sense. Or let's simplify things even further. The encoder is used for understanding language, and the decoder is used for generating language. Now, I know this diagram of the encoder plus decoder, or the transformer, is getting quite crowded, so much so that I had to like really shrink down the pictures and like shrink the font size. But not only is it kind of crowded, it's getting a bit complex, and I know that can be intimidating for some. But just remember this, behind the scenes of this really complex diagram of a transformer, when you simplify it down to the bare basics, this is still what's happening behind the scenes. So we have inputs that are passed to the model that has weight. These weights can be thought of as like the brain cells or like the knowledge of the model. The model uses those weights to generate an output, which could be like, oh, I think this is a picture of a dog or a cat. Or in this example, it's used for translation. So we get like the output. Then we use the error/loss to tell our model how correct its translation is or how correct its prediction is of if this is a picture of a dog or a cat, as like 2 simple examples. Once we get this error/loss, we use it to update the weights of the model. Hopefully our model has better weights, so it gives better outputs, so that these better outputs have a lower error/loss, and the process continues. So again, as complex as this diagram has become, just remember this is all that is still happening when it comes down to the basics. All right, that's it for this video. Thanks for watching. See you all in the next one.